Okay, today we're talking about arithmetic and geometric series. So remember, a series is when you take and you add the terms together. So it's a sum. It's not the one. It's not like the sequence with the commas. And when you take and you add the sequences together, there are two series. One is called an arithmetic, and the other is geometric. So an arithmetic series is when you add these arithmetic sequences together. So S sub n, which will stand for sum, partial sum, for the sum of the first n terms of a sequence. So, for example, Ken walks 20 minutes on day 1 and adds 5 more minutes each day after that. Write the sequence for 10 days. So 25, 30, 35, 40, 45, 50, 55, 60, 65. Write the series to determine his total minutes for the 10 days. So now we would just add them. So the first one was a sequence. This is the series. Okay, so find the partial sum for those 10 days. So if you just add it up, I believe you get 425. There is a formula that you can use when it gets a little harder than just adding up these 10 numbers. And that formula is the sum, or S sub n, equals n times a sub 1. Now remember, a sub 1 is the first term. And a sub n would be the last term in your sequence. Because if you're trying to sum 10 numbers, then S sub 10, a sub n would be the last term in your sequence. And that is divided by 2. So it says find the sum of each series using the formula. So if we took that series that I said was 425 and used the sum formula, it would have been S sub 10 equals n, which is 10, times the first term, which is 20, plus the last term, which is 65, all divided by 2. So that's going to be 10 times 85 divided by 2, and 2 and 10 simplify to 5, and 5 times 85 is 425. All right, so again, if we use the formula for these other examples, we are looking for a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, the sum of 6 numbers. So n is equal to 6. So S sub 6 equals n, which was 6, times the first term plus the last term divided by 2. You can also obviously just add these together very easily without using this formula. This formula is, useful with something like example 2 or example 3. It gets a little harder. So it basically turns out that 6 and 2 simplify to 3, and 3 times 70 is 210. So that's the sum of that one. Next, we have 2 radical and 2 added to 2 radical 2, and so on and so forth. So for this one, I need to figure out how many terms there are. Well, it goes from 1 radical 2 to 15 radical 2, so n would be 15. So S sub 15 is n, 15, times the first term plus the last term divided by 2. So that would be 16, 15 times 16 radical 2 divided by 2. 16 and 2 are 8. 15 times 8 is 120. So this is 120 radical 2, this sum. So it works pretty quickly, this formula. The next one, there's 1, 2, 3, 4, 5, 6, 7, 8 terms. So a sub 8. So n is equal to 8. So the sum of the 8 terms is n times the first term plus the last term divided by 2. So that's 8 and 2 simplified to 4 times negative 20, which is negative 80. All right, pretty quick. A little bit different. Using the given information, find the sum of the first n terms. So we have s sub n equals n times a sub 1 plus a sub n divided by 2. So we are looking for 6 terms, the sum of 6 terms. So s sub 6 equals, n is 6, first term is 24, the last term is 0 divided by 2. So that is going to be 3 times 24 because these cancel to 3, and 3 times 24 is 72. All right, on the next one, we have s sub 14 equals 14 times 10 plus. Now, on this one, all I have is d equals 2. I do not know a sub n. I know the common difference. So I'm going to leave this one for a second and find it and then come back to it. So I have to use a formula that involves d. So for this one, I have to use the formula that involves finding the term, which is a sub n equals a sub 1 plus n minus 1 times d, because this is an arithmetic sequence or series. So a sub n is what we are looking for, and that happens to be a sub 14. We know n is 14. We know our first term is 10, and it is, we're looking for the 14th term, which, because I'm summing 14 total terms here, that's what the n means. So 14 minus 1, and I know that the common difference is 2. So the 14th term is 10 plus 13 times 2, which is 26 plus 10. So a sub 14 is equal to 36. So now I can go back in here and plug in for a sub n 36. Once I found this, I can plug it into this formula. So that one took a little bit longer. And then we could do 14 divided by 2 is 7. So it's just 7 times 46, and that is 322. So without even having to list out the numbers, I can use these formulas. All right, next page. Geometric series. So a geometric series is similar to the arithmetic series, except it's these terms that are getting multiplied to get from one term to the next added together. So for the geometric sequence 2, 6, 18, 54, and 162, a sub 1 is 2. Remember, r is equal to any term divided by the previous term. So I could take a sub 2 divided by a sub 1, which is 6 divided by 2, or 3. So the geometric series is 2 plus 6 plus 18 plus 54 plus 162. And in summation notation, this is kind of giving you a little bit of a formula for that. There was our formula to find a term right there at the end. A sub n equals a sub 1 times r to the n minus 1. That was from the previous lesson. So for the series above, 2 plus 6 plus 18 plus 54 plus 62, the 2 is a sub 1. The 3 is the r. So there's your a sub 1 times r to the n minus 1. So the sum of these 5 terms is 2 plus 2 times 3 plus 2 times 3 squared, which is all written there. And remember, you substitute in 1 for n and then 2 for n, which was this term right here, this term, and then this term, then this, then this. You get those by just replacing n with 1, then 2, then 3, then 4, then 5. And then remember, on the graphing calculator, this is how we can also find it. So there's a little bit of review. So now if you want to find the sum a different way, there's also a formula. And so S sub n equals a sub 1 times 1 minus r to the n over 1 minus r is the formula. So if we use this formula on the series above, I would have S sub, there's 1, 2, 3, 4, 5 terms. So I know that n is equal to 5. So S sub 5 is equal to the first term. A sub 1 is equal to 2. 1 minus r is equal to, we found that already, 3 to the 5th, all divided by 1 minus 3. So this is 2 times 1 minus 3 to the 5th, which is 243. And that's all divided by negative 2. So 2 divided by negative 2 is just negative 1. So it's really just negative 1 times negative 242, because that's what 1 minus 243 is. And so our final answer is 242. So if I sum those 5 terms, they should equal 242. And you obviously could use your calculator, but remember, this is a formula useful for various situations and more complicated problems. We're just doing it on some easier ones to start with. Okay, next example. Find the sum of the terms for the geometric sequence. Says a sub 1 is 1, r is 2, n is 12. So again, I know n is 12, so I'm looking for the sum of 12 terms. The a sub 1 was 1 times 1 minus r, they told me was 2 to the n. We know that's 12, and that's all divided by 1 minus 2. So that gives us 1 minus 2 to the 12th is 4,096 divided by negative 1. So that is negative 4,095 divided by negative 1, or just 4,095. Okay, and we don't even need to write out the series. This next one, so, you know, if we didn't want to add these fractions together with getting a common denominator and using our calculator, we can also use the formula for this. So I have 1, 2, 3, 4, 5, 6 terms, so n is equal to 6. So I'm looking for the sum of 6 terms. The first term is 1/3, 1 minus r. Now to find r, I'm going to take the second term divided by the first term, which is the second term times the reciprocal of the first term, which is 1/3. So 1 minus 1/3 all over, 1/3 to the 6th, excuse me, all over 1 minus 1/3. So that is equal to, let's do this, 1/3 times 1 minus 1 over 729. 3 to the 6th is 729. And 1 minus 1/3 is 2/3. So I did 1 over 3, and I did 729 over 729 minus 1 over 729, and that's all over 2/3. So this is going to give me 1 over 3 times 728 over 729. And then I'm going to multiply that by the reciprocal of this denominator, 3 over 2. The 3's cancel. The 2's canceled to 364, and I end up with 364 over 729. And I did that one on my calculator as well, and it was the same thing. All right, another one. Okay, so n equals 8. And then here is my series. So I need to find the sum of 8 terms. So the sum of 8 terms, and again my formula is S sub n equals a sub 1 times 1 minus r to the n divided by 1 minus r. So S sub 8 equals the first term times 1 minus radical 2 divided by 1 is radical 2 to the 8th, all divided by 1 minus r, which is radical 2. So I think we'll just leave this one in terms of a radical. So radical 2 to the 8th is nice because it's even, so it turns out to be 16. So this is 1 minus 16 over 1 minus radical 2, and we'll just rationalize that. So 1, I wrote that wrong, hold on. So we will multiply by 1 plus radical 2 over 1 plus radical 2, and we will get, this is negative 15, by the way, up there. So negative 15 times 1 and negative 15 times radical 2 is negative 15 radical 2. And that's all over 1 minus 2 because the outers and the inners cancel. So I get negative 15 minus 15 radical 2 over negative 1. And all those negatives can be divided out, so it really turns into just 15 plus 15 radical 2. And if you used your calculator, the decimal for that is like 36.2132 dot, dot, dot. That is what 15 plus 15 radical 2 is equal to. So for the next one, you could use the formula, but you might want to write out some of the terms. So just do the one last. So you can write out some of the terms. The terms go, you know, if I put in 1 over 3 to the first plus 1 over 3 to the second. So I'm getting 1 over 3 plus 1 over 9 plus, and I'm going to do that for 5 terms. And so the fifth term is going to be 1 over 3 to the fifth. So that's going to be 1 over 243. So I need the sum of these 5 terms. So I've got the sum of the 5 terms is equal to a sub 1. My first term is 1/3. So it's going to be 1/3 times 1 minus. To get from one term to the next, you have to multiply by 1/3. So r is 1/3. And that's going to be raised to the 5th. And that's all divided by 1 minus 1/3. So we're kind of back to the same kind of problem as we had last time. So that's 1/3 times 1 minus 1 over 243, all over 2/3. All right, I need more room, so I'm going to go to the back. I'm going to go get myself an extra page. Or maybe I'll just bring it up here. That's fine, I'll do that. So then I'm going to make this in here 243 over 243. So I get, I'm going to run out of room if I do that. I'll do that afterwards. So I get 1 over 3. I can take right away now here and multiply this by 3 over 2, and I can multiply this by 3 over 2. And this denominator simplifies, so I'm really left here with the 3's canceling. I'm really left with 1/2 times 242 over 243. And then if you simplify that, these cancel to 121. So I end up with 121 over 243. And then I need to add on this one piece on the end, so it's really 1 plus, which is really just 243 over 243. If I convert 1 to 243 over 243, my final answer is 364 over 243. So this kind of went down here, and then it wrapped up to there, okay? You could also use your calculator and do the summation as well, but they'd asked us to use the formula, so I did. All right, a couple of applying skills. Maddie is learning to snowboard. She begins by practicing 1 hour on the slope the first day. So 1 hour, and then she adds 0.2. So it'd be 1, 1.2, 1.4 each day until she gets to 3 hours. So how many days did it take Maddie to reach her goal? So we're kind of looking for what n is. So for part A, I'm going to list out. I know A sub 1 is 1. I know D is 0.2. It's arithmetic because I'm adding. That's why I said D. I know A sub n is equal to 3, and I'm looking for n. I don't know. That's what I need. So I may need to use this formula. A sub n equals A sub 1 plus n minus 1 times d. That's to find a term. That was the previous lesson. We know A sub n is 3. That's the last term. A sub 1 is 1. We're looking for n, and we know d is 0.2. So we have 3 equals 1 plus 0.2n minus 0.2. So if I subtract 1, I get 2 equals 0.2n minus 0.2. And if I add 0.2, I get 2.2 equals 0.2n, and divide both sides by 0.2, and you get n is 11. So if you literally counted 1, 1.2, 1.4, all the way up to 3, going by 0.2s, it would be 11. Okay? So that is part A. For part B, how many total hours did she practice? This is asking for the sum. So S sub n equals n, because it's arithmetic, times A sub 1 plus A sub n divided by 2. So we are looking for the sum now of 11 terms. So it's 11 times, now we know n is 11. A sub 1 is 1. A sub n we know is 3 divided by 2. So the sum of all 11 terms is 11 times 4, or 44 divided by 2, which is 22. All right, last one. Keegan started a job that paid $20,000. Then she received a raise every year after that of $800. So it's $20,000, then $20,800. Then $21,600. Okay. So what amount was Keegan earning after 10 years? Okay, so we've got, again, some information. A sub 1 is 20,000. We know n is 10. We know the common difference. This is, again, adding, so it's a arithmetic sequence. So we know that d is 800. I do not know the last term. I don't know a sub 10. I'm looking for that. I'm looking for a sub 10. That's what we want. So I'm going to, for a, use a sub n again equals a sub 1 plus n minus 1 times d. So I'm looking for, after 10 years, what would she be making at the 10th year? Not the total. That will be part B. So 20,000 for a sub 1 times plus n, which is 10 minus 1, and d is 800. So she will be making on the 10th year 9 times 800 plus 20,000. So 20,000 plus 7,200, or 27,200. So that's the answer for the first part. For part B, now they're asking how much had she earned in total over the 10 years. So S sub 10 is equal to N, which is 10, times A sub 1, which is 20,000, plus A sub N. What is the 10th term? We now know that A sub 10 is 27,200. So 27,200 all divided by 2. And I'm just going to divide those right away and say that's 5. So it's 5 times, this is 47,200. So she would have earned 216,000 after 10 years. And that should make sense. Okay, that is it. A little bit shorter tonight, this night.